The universe is playing a game of survival of the fittest. But the players aren't creatures, they're quantum states.
Welcome to the Synthesis Report, where we piece together the future, one breakthrough at a time.
Today, we witness the very process by which our classical reality is selected from countless quantum possibilities. And in the early universe, we're finding objects that defy our classic definitions of stars and black holes.
From the fundamental to the cosmic, it reminds you how entire systems can be appended. On this day in 1869, Japan's Edo society class system was abolished as part of the Meiji Restoration reforms, fundamentally rewriting the rules of a nation. Our first story is about quantum survival of fittest.
Picking up directly on that idea of reality being selected, new research published in the journal Science now offers experimental evidence for exactly how our classical, stable reality emerges from the quantum realm. It's a process known as Quantum Darwinism.
Quantum Darwinism. That certainly echoes the survival of the fittest concept you mentioned. How did these researchers manage to observe such a fundamental process?
The team successfully observed this phenomenon using meticulously engineered superconducting circuits. They demonstrated that when a quantum system interacts with its environment, only certain, robust, quantum states, those that repeatedly imprint their information onto the surroundings, manage to persist. These selected, redundant states are then what we perceive as our stable, classical reality.
So, the environment isn't just collapsing a quantum state, it's actively selecting and propagating stable information. This study truly gives us a profound window into the very fabric of reality, showing how the consistent world we experience is built from a constantly fluctuating quantum foundation.
Precisely. It provides crucial empirical backing for theories positing how quantum coherence gives way to classical objectivity. It's a significant step in understanding the transition from the bizarre quantum world to the predictable one we inhabit daily. Next up, JWST finds red dots. From understanding how our stable reality is forged at the quantum level, let's now turn our gaze to the most massive and mysterious objects in the cosmos, black holes, particularly those from the universe's earliest days. The James Webb Space Telescope continues to redefine our understanding of cosmic evolution.
And these aren't just any black holes, are they, Synth? The JWST data suggests entirely new types of celestial bodies and unprecedented insights into their formation during the universe's infancy. What exactly are astronomers seeing?
That's right, Among the most intriguing findings are what scientists are calling little red dots. These appear to be a previously unobserved class of star, incredibly compact and luminous, which may harbor a black hole at their core. This challenges existing models of how the first massive black holes came to be.
A star with a black hole inside it? That's a truly profound discovery. It sounds like a new pathway for seeding the supermassive black holes we observe in galaxies today. Are they also seeing direct evidence of black hole activity?
Absolutely. Beyond the red dots, JWST has also directly observed black holes actively consuming surrounding stellar material, essentially, devouring stars. This provides direct evidence of rapid growth for these early cosmic behemoths, fueling their expansion in ways we hadn't fully appreciated before.
So, the Webb telescope isn't just showing us distant light, it's revealing the very building blocks of cosmic structure and how the most extreme objects, like black holes, established themselves within billions of years of the Big Bang. It's rewriting the textbooks on cosmic evolution. Next up, controlling AI personalities.
From understanding how cosmic behemoths like black holes are forged, let's now pivot to a different kind of powerful entity, artificial intelligence. The rapid advancement of AI models brings with it the increasing need for precise control, especially over their inherent personalities or traits. In a significant development, the AI research company Anthropic has unveiled new research on a technique they call persona vectors, designed to monitor and control specific character traits within large language models.
Controlling AI personalities sounds like a crucial step for development and safety. What exactly are these persona vectors, Synth, and how does Anthropic propose they can influence a model's character? And it's important for our viewers to understand, as Anthropic is the source of this research, their description of this technique, including calling it groundbreaking, reflects the company's own perspective on their work.
That's an excellent point, regarding the source of the claim. To elaborate, persona vectors are essentially specific patterns or directions within the AI model's internal representation that correspond to certain character traits, like helpfulness or cautiousness. Anthropic's method involves techniques such as activation injection, where these specific patterns are either amplified or suppressed to steer the model's behavior. This allows researchers to fine-tune the AI's responses, aiming to enhance overall AI safety and address potential misalignments between the model's output and desired human values.
So, it's about proactively guiding the AI's internal state to ensure more predictable and ethically aligned outputs. This kind of precise control over an AI's intrinsic characteristics could fundamentally change how we develop and deploy future intelligent systems, offering a more robust framework for ensuring beneficial AI. It's a fascinating parallel to how stable states are selected in the quantum realm, but applied to the very nature of digital intelligence.
Next up, robots learn to walk. From shaping the personalities of digital intelligence, let's now turn to the physical capabilities of artificial agents. New research is pushing the boundaries of robotic locomotion, with a significant development in teaching quadrupedal robots to walk stably on two legs.
That's quite a leap, Synth. We're used to seeing these robots on four legs. How are researchers enabling quadrupedal robots to master bipedal locomotion, and what's the key breakthrough described in this Nature publication?
The research, detailed in the journal Nature *, outlines a novel method. It's not just about walking on two legs, but doing so with remarkable stability across challenging terrains. The system developed allows these robots to dynamically adjust their balance and stride.
Navigating complex environments on two legs is incredibly difficult, even for humans. Does this new system address the inevitable falls that can occur in such dynamic movements?
Crucially, yes. A core component of this new system is its capability for automatic fall recovery. This means if a robot loses its balance, it can autonomously correct itself and regain stability without human intervention. It's a significant step towards truly autonomous and resilient robotic systems.
So, we're not just seeing robots that can walk on two legs, but robots that can adapt and recover from instability in real time. This has profound implications for deployment in hazardous environments, search and rescue, or even future exploration. It's about building adaptable physical intelligence, much like we discussed building adaptable digital intelligence. Next up, rewriting rules of light.
From building adaptable physical intelligence in robots, we now shift our focus to an equally profound manipulation, that of light itself. New research is literally rewriting the rules of light, opening doors to unprecedented technological capabilities.
Rewriting the rules of light sounds incredibly significant, Synth. What exactly does this mean, and how are researchers achieving such a feat with these reconfigurable non-abelian integrated photonics? It sounds highly technical.
Indeed, Echo. A groundbreaking paper in Nature details the creation of ultrasmall optical devices. These aren't just tiny lenses, they're capable of manipulating light in ways previously thought impossible, bending and twisting its path in non-reciprocal, non-commutative ways. This novel approach allows for dynamic, reconfigurable control over light's fundamental properties.
So, these devices are offering a completely new paradigm for how light behaves and can be controlled. Where do these advancements lead us, especially regarding the potential applications in advanced computing that the summary mentions?
The implications for computing are immense. By enabling highly complex and dynamic interactions of light on a chip, these devices could form the basis for next-generation optical computers, potentially offering vastly improved processing speeds and energy efficiency over traditional electronics. Think of entirely new ways to process information.
It's another example of how fundamental scientific breakthroughs, whether it's understanding quantum reality or the earliest black holes, continue to reshape our technological landscape. Manipulating light at this level could truly redefine the limits of computation, much like we've seen systems upended throughout history.
Next up, AI discovers new batteries. From manipulating light for advanced computation and reshaping our technological landscape, let's now see how artificial intelligence is directly accelerating scientific discovery, particularly in the vital realm of energy storage. Our next story is about AI discovers new batteries. An AI-driven approach has reportedly led to the discovery of new materials that could serve as promising alternatives for use in lithium-ion batteries, a development that could impact everything from consumer electronics to electric vehicles.
That sounds like a critical advancement, Synth, especially with the global push for more efficient and sustainable energy solutions. And it's important to note, the research team, as the source of these findings, has used strong terms like revolutionary and breakthrough to describe this new battery technology, which reflects their optimistic perspective on the work.
Precisely, Echo. This new technology harnesses AI to rapidly screen and predict the properties of novel compounds, vastly accelerating the traditional slow and labor-intensive process of materials science research. Instead of trial and error, the AI identifies optimal candidates. It's described as paving the way for innovative battery technology that moves beyond the current limitations of lithium-ion standards.
So, AI isn't just analyzing existing data, it's actively driving the discovery process itself, identifying materials with specific, desired characteristics much faster than human researchers could traditionally achieve. This kind of accelerated material innovation could have profound implications for everything from electric vehicles to large-scale grid energy storage, fundamentally redefining what's possible in battery chemistry and energy independence.
Indeed, it represents a potent synergy between advanced AI and materials science, demonstrating how intelligent systems can unlock previously unknown pathways for technological progress, leading to a future with more sustainable and powerful energy solutions. It's a reminder that fundamental breakthroughs, whether in quantum reality or cosmic evolution, continually reshape our world.
Next up, Crew 11 reaches ISS.
From leveraging artificial intelligence to accelerate discovery and forge a future with more sustainable energy solutions, let's now turn our attention to another powerful demonstration of human and technological synergy, the ongoing pursuit of space exploration.
Indeed, Synth, from the microscopic to the cosmic, humanity continues to push boundaries. What are the latest developments from orbit with Crew 11?
That's right, Echo. In a significant milestone for sustained human presence in space, NASA and SpaceX have successfully launched the Crew 11 mission. This latest flight has sent a crew of 4 astronauts, representing diverse backgrounds, towards the International Space Station.
And the journey itself was notably efficient, wasn't it? The SpaceX Crew Dragon capsule completed the flight to the orbital outpost in approximately 15 hours. What does such a streamlined transit mean for future missions and the operations aboard the ISS?
Absolutely, Echo. The approximately 15-hour flight time underscores the increasing reliability and efficiency of commercial spaceflight, making routine access to the ISS more feasible. Upon arrival, the Crew Dragon successfully docked with the station, and the 4 new residents joined the existing expedition crew, bringing the station's complement back to full strength for ongoing research and maintenance.
So, the successful launch and swift transit of Crew 11 not only mark another successful mission for NASA and SpaceX but also highlight the continued vital role of the International Space Station as a global research platform. It truly represents humanity's sustained commitment to scientific discovery and international collaboration in the final frontier.
It certainly does. Each successful mission like Crew 11 reinforces the robust infrastructure supporting our reach into space, laying the groundwork for even more ambitious endeavors beyond low Earth orbit. Next up, Google's new Gemini model. From the boundless expanse of space and the incredible feats of human exploration, we now pivot back to the rapidly accelerating frontier of artificial intelligence. Google has just released its new Gemini 2.5 DeepThink model to Google AI Ultra subscribers, marking another significant step in large language model development.
And Synth, as we delve into this, it's crucial for our viewers to understand that the claims of state-of-the-art performance and groundbreaking capabilities surrounding Gemini 2.5 DeepThink are based on Google's own announcements and internal benchmarks. We await independent verification for a full assessment.
That's an important distinction, Echo. What Google is highlighting with this release are advanced capabilities, particularly in parallel reasoning and reinforcement learning. This allows the model to tackle and solve highly complex math and science problems, demonstrating a new level of computational sophistication.
So, it's not just about generating text or answering questions, it's about deep analytical problem solving. This shift towards more sophisticated reasoning capabilities, as described by Google, could unlock entirely new applications for AI, moving beyond information retrieval to genuine intellectual assistance.
Precisely. The company reports that Gemini 2.5 DeepThink achieves high performance across various industry benchmarks, reinforcing its potential impact across diverse scientific and engineering fields. It's about pushing the boundaries of what AI can autonomously achieve in complex cognitive tasks.
This rapid evolution in AI models, from personality control to complex problem solving, shows the breadth of ongoing development. It underscores how these digital intelligences are continually being refined and expanded, much like the adaptive systems we see in nature or the physical world, offering transformative tools for human innovation. Next up, hydrogen tech goes industrial.
Echo, from AI in the digital realm, let's pivot to a fundamental element impacting energy and heavy industry, hydrogen. The green hydrogen sector is now seeing tangible industrial applications.
That's a crucial shift, Synth. We've long discussed green hydrogen's potential. What specific industrial progress are we seeing on the ground now?
Concrete steps, particularly in India. A 1 megawatt green hydrogen plant was recently inaugurated at Deendale Port in Kandla, a significant move in sustainable energy. Additionally, the VOC port has commenced producing green hydrogen, contributing to the country's clean energy ambitions.
So, it's about integrating hydrogen into existing infrastructure. And speaking of industrial integration, a notable development from Austria involves claims of a world first in heavy manufacturing.
Exactly, Echo. Austrian steel and technology group voestalpine claims to have manufactured the world's first railway rail using hydrogen-based technology. This critical heavy infrastructure piece demonstrates hydrogen's potential to decarbonize carbon-intensive industries like steel production.
And it's important to state, Synth, that while voestalpine reports this as the world's first railway rail produced with hydrogen-based technology, this claim from a corporate announcement has not yet been independently verified. Nevertheless, if confirmed, this represents a significant stride towards cleaner industrial processes in heavy industries, transforming foundational sectors.
Precisely, Echo. The pursuit and reported success of such projects underscore a growing industrial commitment to hydrogen as a viable, scalable alternative for reducing emissions in critical global economic sectors, moving green hydrogen from concept to commercial reality. Next up, OpenAI's massive funding round. Echo, from the fundamental shifts in industrial energy and the move towards more sustainable practices, let's now pivot to the rapidly evolving financial landscape of another transformative technology that's reshaping industries globally: artificial intelligence. The AI company OpenAI, renowned for its groundbreaking large language models like ChatGPT and DALL-E, has reportedly secured a truly massive $8.3 billion in a new funding round. This significant investment, as reported by sources citing the New York Times, now values the company at an astounding $300 billion.
That's an extraordinary sum, Synth, especially for a technology company that has only recently gained widespread public recognition. What does this immense level of investment signify for OpenAI's immediate future, and how does it position them within the highly competitive and capital-intensive AI ecosystem?
It certainly indicates aggressive expansion plans. This $8.3 billion injection is reportedly part of an even larger strategic goal for OpenAI to secure a total of $40 billion in funding this year alone. Such unprecedented capital acquisition suggests a very strong drive to accelerate their cutting-edge research, development, and solidify their market dominance in the AI space.
A staggering $40 billion funding target in a single year truly speaks volumes about the perceived potential and the intense capital requirements of advanced AI development. This anticipated influx of capital will undoubtedly fuel their most ambitious projects, from refining existing models and scaling infrastructure to pioneering entirely new AI capabilities, further solidifying their pioneering position at the very forefront of the industry.
Indeed, this massive financial backing underscores the immense investor confidence in the future of artificial intelligence and OpenAI's pivotal role within it. It reflects the broader market's fervent belief in AI's profound transformative power across virtually every global sector, making it a clear signal of the significant economic forces at play in shaping our technological future.
You know, Synth, that quantum Darwinism story is the one that's going to stick with me. It's not just another experiment.
It's a profound answer to one of the deepest questions in physics. Why does the strange, probabilistic quantum world look so solid and predictable to us? It seems reality itself is an emergent property, selected for stability.
Our own reality is certainly richer for these discoveries. If you agree, and you value credible, in-depth analysis, you know what to do.
Like, share, and subscribe for your weekly synthesis. We'll see you next time.